Here's a question. If I give you 10 and 3, how do you get the quotient without using divide? And one more wrinkle. If the answer is 3 point something, you keep just 3, not the fraction. Let's pin down the example. 10 divided by 3 should return 3. So what are we really counting? How many full 3s fit inside 10? Try the obvious thing. Keep subtracting 3 from 10 until you can't anymore, and count how many times that worked. For this example, that feels fine. 3 subtractions answer 3. But pause here. What if the dividend were huge and the divisor were 1? Then we'd subtract 1, over and over, billions of times. The answer is simple, but the path is painfully long. So what are we wasting? We keep removing the same divisor one little chunk at a time. What if, instead of one chunk, we remove the biggest chunk we can prove still fits? And here's the move. Keep doubling the divisor like folding a paper strip to make bigger equal chunks fast. Same idea, said another way. We jump by powers of 2 copies of the divisor, not by 1 copy each time. You might think we should work with positive numbers because they look cleaner. Watch out, that can overflow at -2 to the 31st. So the safe rule is this. Convert both numbers to negatives, do the work there, then fix the sign at the end. Let's walk it. Start with 10 and 3, then flip both to -10 and -3. Now ask the main loop question. Is -10 less than or equal to -3, meaning at least one chunk still fits? Begin one chunk. Current value is -3 and this chunk counts as one copy. Can we double it? -6 still fits inside -10, so yes, double both the chunk and the count. Try doubling again. -12 is too far, so we stop growing this chunk here. Now subtract that whole chunk. -10 minus -6 leaves -4, and the quotient gains 2. Loop again. -4 still fits at least one -3, so start a fresh chunk from the original divisor. This time doubling fails right away, because -6 does not fit inside -4. So subtract one divisor. -4 becomes -1, and the quotient becomes 3. Now the loop stops. Notice what changed. We did not peel off one divisor at a time. We removed the largest safe doubled chunk each round. The work grows much slower than repeated subtraction, and we use only a few variables while we go. Let's write it. First, guard the one bad overflow case, then record whether the final sign should be negative. Next, push both inputs into the negative side. That's the safety rule from the trace. Here is the main loop. Start a chunk, double it while it still fits, then subtract that chunk and add its count. Last step, put the sign back on the quotient and return it. And that's the pattern. When repeated subtraction drags, start grouping the work into doubled chunks.